Hi guys, it's Mrs. Golding, and we are going to talk about the Pythagorean Theorem for e-learning today. You've been doing a great job with this over the last few days, and so I think this should be cake for you. Remember, Pythagorean Theorem only applies to right triangles. This is our formula, and the hypotenuse, which is the side that is the longest and opposite the right angle, is always our C value. So if we have, just for review, if we have a missing leg, well, that's a problem, isn't it? Don't want to have a missing leg. If one of these is missing, but you know this one, right? You're going to end up squaring your hypotenuse first. So you're going to take your C squared minus whatever you have here, either an A or a B. So we're going to subtract, and that's going to give me that A squared. And remember, at the end, you're always going to take the square root to find your actual value for the missing. Okay, so if you have a right triangle and it's your, let's see if I can, let's go back, that up. Let's say it's your hypotenuse that's missing, okay? And you know these values, then you're just going to add a squared plus b squared to get you that c squared, okay? So remember, missing leg, subtract, missing hypotenuse, add, okay? So let's go ahead and look at what you have for Delta Math today. So it says find the third side, round to the nearest tenth. Okay, there's a calculator embedded in each of these Delta Math activities. So as you go through, I want you to immediately make note of whether or not there's a missing leg or a missing hypotenuse. And remember, the legs make up the right angle, okay? So like we did in class, you can kind of look for that right angle. So this one's missing a hypotenuse, so I know this is an addition problem. So I'm just going to go in and my calculator, let's just go ahead. So we have a 24 and an 18. So 24 squared, and there's your squared right there, plus 18 squared is equal to 900. And I'm going to go ahead and hit enter. And I'm going to take the square root, which is right here, of 900, and that's going to give me 30, which is the length of this side. So 30, and that would be, I don't see any units. I think if there are units in the problem, it's given. We don't need to round. Let's go here. So this, I have an example where I have this leg and I'm missing this leg. So I know my hypotenuse. So this is a subtraction problem, right? All right, so I'm going to always start with your C value. Start here, okay? So 25 squared minus 24 squared. So let's go ahead and back up here. 25 squared minus 24 squared is 49. And we want to take the square root of that. Maybe you know that one. Hopefully you know that one. That's kind of a good one to know. If I can get it to work here. So the square root of 49, if you don't know it, put it in, and it is 7. Okay, so for this, the missing is 7. Good to go. I think you guys got this. If you have problems that they tell you like there's a ladder leaning up against a building, or some streets, or they say James walked 2 miles east. Remember, north, south, east, west. Okay. He's going from his house and he's walking 2 miles east. Then he goes 1.5 miles north. And then you say, how far are James and Sarah's houses apart? Or they might say if there's a road that connects them directly, which would never happen in real life. But they like to say things like that in math problems. So you just kind of read the problem and draw what it's saying. And then you can use these problems to figure out what's missing and then use your Pythagorean theorem. So in the example of the ladder, I'm missing a leg. So I would take my 50 squared minus my 35 squared. This ladder is 35 feet away from the building, and it's a 50-foot ladder, and we want to know how far up is that third-story window that it's placed at. All right, and we know that the whole building thing is like 60 feet. So we just want to know how far this is. Again, we know the C, we know a side, a leg. So 50 squared minus 35 squared. 50 squared minus 35 squared. 1,275. And let's take the square root of 1,275, and we get this. Now, remember, in most instances, it says either round to the nearest tenth or hundredth. So if it said tenth, we would look in the tenths place, which is right here, and this is a 0, so it's less than 5. We would let that all slide. This would stay 35 and 7/10. If it said round to the nearest hundredth, this is a 0, and the number next to it in the thousands place is a 7. This would come up to a 1 because this is greater than 5. So for our purposes, we're just going to say 35.7 or 35 and 7/10. Okay, so 35 and 7/10. Okay, now what would be the length of this diagonal here? This is an addition problem, so this one was a subtraction. This is an addition, and I know that because I know the legs. So 2 squared plus 1.5 squared. 2 squared plus 1 and 5/10 squared is equal to 6 and 25 hundredths. And we want to go ahead and take the square root of that. Remember, that's the last step every time. 6 and 25 hundredths is 2.5. So 2.5 miles, right here, 2.5 miles. Again, we got those. Okay, good to go. Let's go to the next one. Okay, so this is on your delta math. One of the legs, so it's telling me a leg, and it's telling me a hypotenuse. So it's telling me one of the legs. So let's just go ahead and draw it. Doesn't matter what it looks like. One of these is 11. The hypotenuse is 13. And we want to find this one. So automatically know this is a subtraction problem. In your calculator, you're going to take 13 squared, right? Minus 11 squared is going to give me x squared. And then you're going to take the square root of that. Okay, let's go on to the next one. You're going to see some problems like this. What's the length of this dotted line and round to the nearest tenth? Well, let's see. I have one leg here. I don't know this leg. I can see that this is a rectangle. It's showing it to me. It has 4 right angles. Okay, so if this side is 7, I can assume this side is 7. And then I need to find this side right here. Let me mark it in another color. I want to find this side right here. And I can do that using the Pythagorean theorem for this triangle. Okay. So 3 squared is 9. 4 squared is 16. 16 plus 9 is 25. And the square root of 25 is 5. Okay. You can obviously punch all that in your calculator. This is also 5. And so if I know this is 5 and this is 7, I'm looking for a hypotenuse. I take 5 squared plus 7 squared equals c squared. 25 plus 49 equals c squared. You picking up what I'm laying down? Okay. Now this one is giving you an example of that real world problem, but it's in words. So you just have to draw it. If you place a 39-foot ladder against the building, okay, here's the building, here's a ladder, and you're putting it, it's 39 feet. And the bottom of the ladder is 31 feet from the bottom of the building. And we want to know how tall is the building. So are we looking for a hypotenuse? Nope, we got a hypotenuse. We are looking for a leg. So again, this is a subtraction problem. Start with your hypotenuse, 39 squared, minus one of the legs that you know, 31 squared, equals, and in my case, I put an x there, so we'll just put an x squared. And then once you find that, you're going to take the square root. Good to go? Awesome. Guys, hope to see you Monday, and I love to see these assignments coming in. Have a great day.